Okay, so now we are going to start a mock interview for our student Kaustubh Ghosh, and this interview is for BARC.
Yes, sir.
So, Mr. Kaustubh, first of all, you tell us about yourself.
Sir, myself Kaustubh Ghosh, and I am from West Bengal. I pursue my BSc from Vishwabharati University, Shantiniketan, and then I go for pursuing my MSc in IIT Guwahati.
Okay, so you have completed your MSc from there, IIT Guwahati.
Yes, sir.
So generally MSc people go for PhD. You did not try?
Yeah. Sir, I could not even see it in NET exam, CSI NET, and my GATE rank is not so good. That's why I think I will try for next CSI NET and GATE exam.
Okay. So what do you want to do in life actually?
So I wanted to do some good thing that people will remember me as a researcher or scientist.
So do you remember all the scientists in India?
No, but the popular one who get Nobel Prize or such globally known.
Okay. So for this interview, you have prepared some subjects, something?
Yes, sir.
Okay. So what are those subjects?
So my first choice is physical spectroscopy, and second is organometallics, and third is chemical kinetics, fourth is group theory, and fifth is pericyclic.
Okay. So spectroscopy, physical spectroscopy and spectroscopy, same thing or different thing?
Physical spectroscopy means here we for both spectroscopy. For spectroscopy means where we matter and electromagnetic radiation interaction. But for physical spectroscopy, there is we see the translational, rotational, vibrational, electronic motions. But if we specifically say spectroscopy, then it is atomic spectro. It can be atomic spectroscopy, molecular spectroscopy, and different or spectroscopies are there.
What is the use of spectroscopy actually?
Spectroscopy can know if in a jar there is some molecule, we can know its characteristics, its properties. So it will helpful for research. And
do you know chromatography also?
Yes, chromatography is a process where we separate the products. If there is a mixture of products, then we separate by chromatography.
Okay. Okay, sir. You can start.
Okay, Kaustubh.
Yes, sir.
For the electronic spectrum, you said that my favorite topic is physical spectroscopy. So we start with the physical spectroscopy. What kind of information is revealed by the electronic spectra?
Sir, we know about the ground electronic state, excited electronic state. If there is merge in the excited electronic state and some non-bonding states, and also the vibrational characteristics of the molecule can be known from electronic spectroscopy.
Kaustubh, जो आपने you are telling that we know about the ground state and electronic state. Every substance has a ground state and electronic state. So this information is already present. What we reveal from the data of the electronic spectra.
Sir, if there is a pi bond present or non-bonding orbitals present, so where the electron present, we can know from electronic spectroscopy that if there is pi bond or sigma bond present, or which bond is weaker. So this
Again, sigma bond is already present in every chemical compound. Okay, can you tell me how we can reveal that a molecule consists of a homoannular diene or heteroannular diene from the electronic spectra?
so can you repeat? Homo?
How we can get that a molecule contains a homoannular diene or heteroannular diene from the electronic spectra?
Homoannular diene and
Do you know about these homoannular or heteroannular dienes?
sir, I don't understand what is annular.
Okay, Malli, you don't have knowledge about homoannular or heteroannular.
Yes, sir.
Okay, different type of transitions which occurs during the electronic spectra.
Yes, sir. The transitions from sigma to sigma star, pi to pi star, non-bonding to pi star. These types of transitions are occur in electronic spectroscopy.
Okay, which transitions occur at a shorter wavelength among these?
Non-bonding to pi shorter wavelength.
Shorter wavelength, yes.
Wavelengths are sigma to sigma star. It is
Sigma.
shorter wavelength.
Okay, can you give the example of any molecule in which there is N to pi star transition?
N to pi star transition. Non-bonding to pi star. No examples.
Okay, you are not remembering it present, huh?
It's actually not. I can't remember.
Okay. What is a 0 point energy?
Sir, actually, in vibration, in 0 point energy is the in electronic spectroscopy, there is the minima present, but a molecule cannot be present at the minimum energy. It's can have some amount of energy. So this is called 0 point energy. Sir, I can show one image.
Yes, you can
I
show.
Yes, sir. So this is the electronic state of a molecule, and this is the minima of the minima. So its energy is 0, but molecule cannot present at that position. The vibrational level of in between this electronic state can start from this. This is vibrational quantum number 1. 0. No. Vibrational quantum number. So this is 0. Molecule present in that position. Molecule cannot be present at that position. It means at the lowest molecule cannot molecule's vibration cannot be 0. It means so.
Oh, can you draw more energy levels for the non-harmonic oscillator in this diagram?
Yes, sir. Sir, the energy gap between the energy levels are decreasing, and at this position there is a continuum in the means the energy levels are get merged, so there is a continuum present. The energy gap between these levels getting decreased.
Okay, from the vibrational spectra, but how we will came to know that we are obtaining a continuum in a spectra?
So if the molecule reach at this position, the molecule breaks into two separate atoms.
This is an energy level diagram. I am saying that from the spectra of the vibration, which shape of the continuum, which kind of shape represent a continuum?
Sir, from electronic spectroscopy, we can say that the continuum is reached. Or can I show one image?
Yes, you can show.
Okay. So, if molecular transitions occur in a straight line, and we get spectra like this. Intensity in this position, and nu bar is frequency. So sir, this
So
is
find the
the
you were saying it is a continuum.
yes. This region there is we cannot get get any peaks, and this is we can say this is the continuum is continuum is reached.
What this continuum represents? What it signifies?
Molecule breaks into two atoms. The bond break between molecule.
The bond is broken. Okay, in electronic transition, why the
Sir, can you repeat? The voice is breaking. So,
why the transition takes? You are saying na transition are taking in a straight line.
okay, so this is the Frank Condon. This phenomena is a Frank Condon principle. So, according to Frank Condon principle, that the electrons are much lighter than the nucleus. Nucleus are more heavy. So the electronic transitions cannot be when the electronics transitions occurs, the nuclear or the vibration between a molecule cannot be occurred. So that's why the electronic transitions occurs in a straight line. It means when the electron jump from one level to another level, the molecule could not vibrate at that time. So
Okay, fine. If we talk about the Raman spectroscopy,
yes, sir.
then what are a condition for a molecule to show the Raman spectra?
Sir, a molecule should be anisotropically polarizable.
Can you give me examples of anisotropically polarizable molecules?
Yes, sir. Yes, sir. Sir, according to the polarizability ellipsoid, the axis of ellipsoid, if we define is A, it is proportional to the 1 by root over alpha. Alpha is the polarizability. It means if the
Anisotropically polarizable molecule.
yes, sir.
Hydrogen molecule is anisotropically polarizable.
Yes,
or
sir.
isotropically polarizable?
Sir, repeat, please.
Hydrogen molecule is a anisotropically polarizable molecule, or is it a isotropically polarizable molecule?
So it's anisotropically polarizable, I think. It's anisotropically polarizable, sir.
Okay, शिल्पा मैम,
यस सर।
स्पेक्ट्रोस्कोपी से कुछ पूछना चाहोगे?
हाँ जी सर, एक दो क्वेश्चंस हैं।
पूछिए मैम, पूछिए।
ओके ओके। हेलो कौस्तव।
Yes, sir. Yes, ma'am.
हाँ जी, लाइक यू नो कि बार्क जो है जनरली, अगर आप बार्क के लिए लाइक प्रिपेयर कर रहे हो फॉर इंटरव्यू के लिए, तो आपको पता होगा लाइक बार्क में बहुत ज्यादा काम होता है, लाइक किस तरह का फ्यूल हम बनाएंगे, ठीक है, लाइक रॉकेट्स एंड ऑल के लिए, और जितना भी हमारा जो न्यूक्लियर फ्यूल्स वगैरह हम बनाते हैं उसकी जो वेस्ट होती है उसके डिस्पोजल के लिए बार्क जो है वो काम करता है ना। इसके साथ साथ वो अलग अलग एरियाज में भी काम कर रहा है, लाइक सर ने आपसे स्टार्टिंग में पूछा था एप्लीकेशंस एंड ऑल, तो कुछ एप्लीकेशंस मैं ही आपको बता देती हूँ, लाइक इंडस्ट्रीज में, लाइक मेडिसिनल इंडस्ट्री, एग्रीकल्चर इंडस्ट्रीज में, है ना, डिपेंडिंग अपॉन कि किस तरह का उन्हें कंपाउंड चाहिए, ठीक है, लाइक कभी कभार डिफरेंट टाइप्स ऑफ आइसोटोपिक कंपाउंड्स is very much required by some particular type of industry. So can you tell me how can we differentiate two different isotopes? Using spectroscopy की हम अगर isotopes को हमें differentiate करना हो, let's say हमने कोई compound synthesize कर लिया, हमें confirm करना है कि whether it is containing our required isotope, yes or no, हम किस technique से use करेंगे, क्या technique use करेंगे उसको?
Okay. So I take one example. If I take HCl or DCl, we can, if we are said to differentiate between HCl or DCl, so there is a change. We can differentiate with both by rotational spectroscopy and by vibrational spectroscopy. So in rotational spectroscopy, the energy term comes equal to J plus 1. So B here in rotational spectroscopy, the energy terms came J plus 1. B is proportional to 1 by mu. So for HCl and for DCl, there is a HCl mass is for H mass is 1 and deuterium is 2. So the mu means the reduced mass getting increased. So the energy gap between the levels is decreasing. So if we compare the HCl spectra and DCl spectra, the energy gap between the lines is decreasing first. And for vibrational, we can also for vibrational there is the frequency mu is equal to 1 by proportional to root mu. So here is also, if the reduced mass increasing, the frequency for this bond vibration is getting decreased. So we get the peaks at lower frequency.
Okay, fine. Mass spectroscopy के बारे में आपको कुछ पता है? Do you know any principle of mass spectroscopy?
So, ma'am, first of all, mass spectrometry, here we cannot use any EMR, means electromagnetic radiation. We breaks the molecules into ions or radicals, and and we channelize it via a one potential gradient, potential tube. So the molecules molecules at a different position, the molecules get molecules get heat that according to their mass. So from there we can say that what is this, what that mass, and from there we say that what is the molecule, formula of the molecule. So
okay, like कोई भी molecule है, let's say सिंपल एसीटोन ही है, तो उसका किस तरह का मास आप मास स्पेक्ट्रा एक्सपेक्टेड करते हो ये अगर आएगा?
Ma'am, acetone, first of all, acetone, we get CH3 radical one, another is CH3 CO radical I get, and if the hydrogen are actually I don't know the splitting properly. The
Means
rules of
an idea about ki like acetone will split in different times. Okay, fine, thank you sir. I guess आगे next topic हम ले सकते हैं sir.
Okay, Costa.
Yes, sir.
Tell me, what is the use for study of kinetics of reactions?
Sir, can you repeat actually?
What is the use of study of kinetics of reactions?
Okay. So kinetics is used to see the reaction rate, whether it is a slow reaction or fast reaction. The half-life means when the substance concentration we use that gets completely finished, and also the mechanism of the reaction we can detect from chemical kinetics.
Okay, fine. Suppose you are the reaction is zero order. Reaction is
Zero order.
zero, and we are drawing a graph between a half-life for a zero order reaction and concentration of a reactant.
Okay.
What
Okay,
will be the shape of graph? We are drawing a graph between T1/2 and concentration of reactant.
Okay. Sir, just 1 minute. Here, sir, T half proportional to the concentration and of the substance. So, if we draw T half, y 0, so this curve goes like that. Its slope is 1/2k.
If we draw between a rate of reaction and concentration of reactant,
Rate of reaction and concentration of the reactant. Okay. So it is a straight line. It could not depend on.
okay, can you tell me the units of K?
Okay. Yes, sir. It's mole per liter second. So mole per liter into second. It's
Mole per liter into okay. Second, denominator में है कि numerator में है?
so it's in the denominator. Say liter inverse, second inverse. Mole liter inverse, second inverse.
Okay. What is difference between a threshold energy and activation energy?
Threshold energy. So threshold energy. I think, sir, they are equal.
You think they are equal? Then why we have given the different names? If cost of is one, then its names will remain cost of.
Threshold energy and activation energy.
Okay, for the nuclear reactions, for the
Yes, sir.
nuclear reactions, if we want to study the kinetics of the nuclear reactions, then which order it will follow?
So it is the first order reaction.
And the rate of reaction will depend upon which parameter?
Rate depend on the substrate concentration in power 1.
In nuclear reactions,
Okay.
it will depend on rate of disintegration. How the radioactive material disintegrate.
So can you repeat the question?
Well, how the radioactive disintegration rate of reaction will depend upon the which parameter?
For nuclear reaction.
Okay, which theories explains the study of kinetics of reactions? Which are different theories?
Yes, there is two theory. One is collision theory and another is activated complex theory.
According to collision theory, rate of reaction depend upon which factors?
According to collision theory, the speed of the molecule, the area of the molecule, and numbers of the molecule.
Speed of molecule, area of molecule.
Area. Yes, area. Pi r square is the area. Yes, area of the molecule and the numbers of the molecule.
It also depends upon collision frequency. Have you heard about this?
Yes, it's depend on collision frequency and orientation factor also. Did I miss that?
Collision frequency could
Sir,
define the
sir, I say the collision theory, there is three terms: collision frequency and the energy factor and orientation factor. Three terms. The collision frequency depends upon the temperature, the speed of the molecules, number of the molecules, and the area of the molecules. That time I mistake that. The collision frequency depends on these three parameters, and the rate also depends on collision frequency, energy factor, and orientation factor according to collision theory.
Okay, enzyme catalysis follows a which kind of kinetics?
Enzyme. Okay. In enzyme catalysis, it is concentration dependent. If the concentration of the substrates is if the concentration of the substrate is less than the Michael maintenance constant, then it follow the first order reaction. And if the substrate concentration is less than Michael maintenance constant, then it follow zero order reaction.
Can we study the kinetics for natural processes?
A natural process means
Natural processes which are occurring in nature. Spontaneous processes which are occurring in nature.
Actually, I am not getting which type of which reactions, sir.
Nick, there are many natural processes which are occurring in a universe. Can we study the kinetics of that reactions?
Yes, sir. Yes, sir, we can study the kinetics. It's whether it's slow or fast. We can study.
Okay, whether it is slow, whether it is fast. But
Yes, sir, we can.
but during the chemical kinetics, we concentrate upon the reactions which are occurring at the moderate rate.
Sir, for fast reaction, we can study the kinetics also.
Okay, Shilpa ma'am,
Yes, sir.
हाँ जी कुछ पूछना चाहोगे?
Sir, only 1 to 2 questions maximum आपने पूछ लिया है.
कोई बात नहीं.
Hello, Costa.
Yes, ma'am.
हाँ जी, तो आप बताएं ये chemical kinetics में can we find the order of the reaction?
Yes, ma'am.
Okay. Let's say एक reaction है with respect to A, it's a first order, and with respect to reactant B, it's second order. So what is the differential rate equation for that reaction?
Okay. Ma'am, this is the rate, and this is rate constant. It's depends on order is 1, and for B that's second order.
Okay, fine. अच्छा अब let's say कि how is the rate? Let's say अगर हम concentration दोनों की A और B दोनों reactant की अगर हम concentration को double कर ले तो किस तरह से rate effect हो सकता है?
Ma'am, rate increased by 8 times. Actually, for this R2, okay. Yeah. So 8, okay. 8, 1, B2,
Okay.
It's 8 times.
Okay. Do you know about what is Haber's process?
So, ma'am, it's a process by which we produce ammonia from nitrogen and hydrogen. Mixing nitrogen and hydrogen, we can produce ammonia.
Okay. Is it endothermic reaction or exothermic reaction?
It's endothermic reaction.
Endothermic reaction.
Yes, ma'am.
अच्छा एक बार इक्वेशन लिख के देख लो बताओ किस तरह से रिएक्शन होते हैं रिएक्शन बताओ लिख के बताओ मुझे
Costa, which order it follows? ये कौन सा ऑर्डर फॉलो करती है?
Sir,
फर्स्ट ऑर्डर, सेकंड ऑर्डर, थर्ड ऑर्डर, कौन सा ऑर्डर फॉलो करेगी ये रिएक्शन?
Sir, we have to define it experimentally. Actually, I not know properly.
ये रिएक्शन तो होगी नहीं जैसे आपने लिखी है. अगर यही कंडीशंस देते हम तो रिएक्शन तो होगी नहीं ये.
No, sir. We have to put if iron as a catalyst, and we have to increase the temperature up to 200 degrees centigrade. That's after that the reaction can proceed.
Okay, मतलब catalyst is important.
Yes, sir. Catalyst is needed.
Without catalyst, reaction cannot occur.
No, sir.
How much we can increase the concentration by any amount, but reaction will not occur. So it is a zero order reaction.
Sir, repeat the question. Actually, I do not.
Without catalyst, the reaction is not occurring. then it will be zero order reaction. हाँ जी मैम, पूछिए आप.
Done, sir.
Okay, Kaustav, then we move to the group theory.
Yes, sir.
Okay, so what is a group theory? यही बता दो पहले मेरे को आप. Group theory होती क्या है?
So, group theory, where we group theory में हम molecules का symmetry check करते हैं.
Molecules का symmetry check करते हैं. वो तो हम देख के भी check कर सकते हैं. By seeing the object, we can study.
But by using group theory, we can say that if there is possible, if the molecule is by saying group theory, we can we can classify the molecules, and by just their classification, we can say if that is molecule, if in that classification the molecular polar, non-polar, we can just say by
group theory.
Yes, sir. That if the transitions are possible.
के बारे में बात का यार, अभी तो आपने कहा सिमेट्री स्टडी करेंगे, अब पोलर और नॉन पोलर भी स्टडी कर लेंगे.
सर ग्रुप थ्योरी से मतलब पहले तो सिमेट्री
ठीक है, कोई बात नहीं. मेरे को ये बताओ, एक आपके पास क्यूब है, पता है ना क्या होता है?
यस सर.
एक स्फीयर है. कौन सा ज्यादा सिमेट्रिकल है? विच इज मोर सिमेट्रिकल?
स्फीयर.
व्हाई? Give me answer on the theory.
Okay. For a sphere, we have to for a cube we have to rotate rotate it in any axis. Say x, we have to rotate it 90-degree angle. Then we get say equivalent structure. But for sphere, there is minimum. If we rotate it by a minimum angle, we can get the same equivalent structure. So the sphere is more.
Okay. What are operation? How we define the operation in a group theory?
Operations. From one structure to get that identical structure, how many equivalent structure we have to go? So 1 minute, I just came. Yes, from one structure, and if we rotate it and for getting the next identical structure, how many equivalent structure we are getting, that that is count in the
axis. Okay, axis of symmetry क्या होती है?
Axis of symmetry, one imaginary axis passes through the center of gravity of the molecule, and it's rotate by an axis, and getting the equivalent structure. So that is and by which angle we have to rotate, and getting the equivalent structure, that's name is axis of symmetry.
H2 molecule में कौन सी axis of symmetry होगी?
Sir, H2 molecule in along the bond there is the infinity, means It's a there's the infinity axis, and from the center of the gravity of the molecule, there is a C2 axis of symmetry.
Okay, suppose we have a dxy orbital
dxy, okay.
and dx square minus y square.
Yes, sir.
Well, we have to convert dxy orbital into dx square minus y square. What will be the order of x's? Have you got the question?
Yes, sir. Yes, sir. Just I do this, 20, 50, 40, C8, sir.
Yes.
C8, sir.
What will be its order? This is a C8 as a axis. What is its order?
Order is sir 8.
Okay, fine. What are the different kind of planes a molecule can contain?
Sir, there is three types. First is the horizontal plane, and another is a vertical plane, and third is the dihedral plane.
Third is a
Dihedral plane.
dihedral plane. Okay. Suppose you are having a sigma, you know, sigma plane is represented by sigma.
Yes, sir. Yes, sir.
If its power is odd, its power is odd.
Or
Suppose it is sigma 4, sigma raised to power 4.
4.
Sigma raised to power 4. And after operating all the operations of the sigma 4, what will be the resultant?
Is sigma 4 equal to identity, means there is no change in the molecule.
No change in the molecule. Okay, what is group?
Group, sir, for a molecule which for a molecule different types of symmetry elements are present, such as axis of symmetry, plane of symmetry, and inversion symmetry, alternating axis of symmetry. So if we group them all, so if we group them all, that's represent the definition. I actually it's not getting.
To form a group, it should follow which properties?
So there are 4 properties. As a point group,
Yes, point group.
so there is 4 property. First is the closure property. Second is the existence of identity. Third is the existence of inversion, and fourth is associated law property, associative property.
What is the point group of water molecule?
C2V.
Can you draw the character table for C2V?
Character table, it takes time, sir.
It takes times.
Yes, sir.
Okay. Which will be the operations the water molecule will have?
So it's C2V. It means it's have one identity, one C2 axis of symmetry, and 2 sigma V, means vertical plane. two plane of symmetry and the plane are vertical.
Can you give me the example of any point group with a chiral point groups?
Chiral point groups, yes, sir. It's S2N. S2N point groups is chiral.
H2N.
S2N.
Why we say it? Why say it is a chiral?
I has is an image alternative axis of symmetry.
Some applications of group theory.
So I make a mistake on that. Actually, for chiral, I don't know the chiral point group. Actually, I make the mistake.
Okay, leave it. Okay, tell me any two applications of group theory.
Okay. So we can separate molecules. Is it a linear molecules? It is a spherical symmetric molecule, symmetric top, and asymmetric top. We can classify these four types of molecules, and this is the help us to understand the rotational spectroscopy. And this is we from group theory we can learn if the transitions are allowed or forbidden. We can say it is Raman active or IR active. We can also say via group theory.
Okay, Shilpa ma'am.
No, sir. No, sir.
Okay, Kaustav. Now we move to the pericyclic reactions.
Yes, sir.
Can you give me an example of any pericyclic reaction?
Yes, sir. Sir, this is a electrocyclic. If we give heat or light, so we get.
We give both. It is thermally allowed or photochemically allowed. There are some selection rules. दोनों इकट्ठे ही दे देंगे हम.
Yes, it takes. Sir, 1 minute.
What is this ODC?
Sir, it's a short trick. So this reaction is if these two hydrogens are in the cis position, then the reaction occurs only in presence of light.
Okay, suppose we are having a molecule 2,3-dimethyl-butadiene.
So 2,3
dimethyl
dimethyl
butadiene.
Okay.
Okay, and we have to do the cyclization of this compound. It will be thermally allowed or it will be photochemically allowed.
So it is 2,3 dimethyl butadiene. So it is allowed by both by heat and light, but we can get the reaction if we have photochemical conditions.
Okay. What will be a product if we are doing thermally and if we are doing photochemically? Will be any difference in the product?
No, sir. For this, there is no difference. No difference.
बना के देख लो. You can do the reaction.
Yes, sir. So for both cases, we get this, but due to ring strain, the molecule only go via this pathway, light.
The rotation will be same for the thermal and photochemical.
No, sir. For
आपने लिखा तो था ODC यहाँ पे नहीं लिखाओगे?
yes, sir. For this case, even con, we have con rotatory, and for this case, we have dis rotatory.
So different isomer will be formed. It will be cis or trans.
No, sir, because there is both are hydrogen, no cis or trans.
Okay, fine.
Okay, sir. So now we can go for feedback.
Okay.
Yes, sir.
Yes, sir.
Okay, fine, Kaustav. It was a good interview. ठीक है, you have a confidence. ठीक है, पर कुछ क्वेश्चन यार आपके गलत थे. ठीक है, ऐसे ना कोई भी टॉपिक आपने अगर बोल रहे हो, आई एम परफेक्ट इन ग्रुप थ्योरी, आई एम परफेक्ट इन पेरिसाइक्लिक, तो व्हाट इज ग्रुप थ्योरी, उसकी एप्लीकेशंस क्या है, पेरिसाइक्लिक क्या है, पेरिसाइक्लिक की एप्लीकेशंस क्या है, इंडस्ट्रियली कहाँ इंपॉर्टेंट है, ये 3-4 क्वेश्चंस तो आपके इनके आंसर्स परफेक्ट होने चाहिए.
Okay, I will work on that.
ठीक है,
Okay,
अगर माय ग्रुप थ्योरी इज वेरी गुड, तो आपको ग्रुप थ्योरी की प्रॉपर डेफिनेशन तो देनी नहीं आ रही यार, तो फिर कैसे कह देंगे हम गुड हो आप?
Yes, sir.
Chemical kinetics, same with the chemical kinetics. ठीक है, I was not satisfied with the what is the use of chemical kinetics. ठीक है, chemical for fast reactions it is impossible to study the kinetics, because for the kinetics we need to know the change of a concentration of any one of reactant or any one of the product. So if the reaction is very fast, how we can determine? We are not having a techniques. ठीक है, we study the kinetics either spectroscopically or by different means. ठीक है, but for fast reaction it is not possible. So we do the kinetics for the only moderate reactions.
Okay. Yes, sir.
Okay. Slow reaction, for the slow reactions also we don't go for the kinetics. You know that the glass also flow. The particles in a glass also flow. ठीक है, अगर ग्लास को हैंग करके रखते हैं तो कुछ सालों बाद वो ऊपर से पतला हो जाएगा, नीचे से मोटा हो जाएगा. ठीक है, पर इतने टाइम तो हम किनेटिक स्टडी नहीं कर सकते ना उसकी. तो वेरी स्लो के लिए और वेरी फास्ट के लिए करते हैं, हम सिर्फ मॉडरेट के लिए ही करते हैं. ठीक है, 0 point energy. Every substance in the universe possess a minimum amount of energy in its ground state. ठीक है, substances हैं उनके ground state में एक minimum energy है. That minimum energy is called as a 0 point energy. ठीक है, 0 point energy के हम वाइब्रेशनल स्पेक्ट्रा में एक्सप्रेशंस ड्राइव तो करते हैं, हाफ एच म्यू.
यस सर.
ठीक है, 0 point energy के एक्सप्रेशन ड्राइव तो करते हैं हम. ठीक है, उसके बाद आपने एग्जांपल्स यूवी स्पेक्ट्रा में मैंने पूछा था N2 पाई स्टार के एग्जांपल्स, यार एल्डिहाइड, कीटोन्स, कार्बोक्सिलिक एसिड, सारों में N2 पाई स्टार रिएक्शंस हो सकती हैं, ट्रांजिशन हो सकती हैं.
ये सर ऑक्सीजन नॉन बॉन्डिंग टू पाई स्टार.
ठीक है ना. तो मतलब आप अपने थोड़े से, क्योंकि जो हमने टॉपिक बोलना है उनका अच्छे से बेसिक, उनकी एप्लीकेशंस इंडस्ट्रियल फ्रॉम बोथ इंडस्ट्रियल पॉइंट ऑफ व्यू से भी कहाँ कहाँ यूज कर सकते हैं यार, ठीक है। बार्क में देख लेना यार, क्योंकि बार्क में न्यूक्लियर रिएक्शंस ही करते हैं हम वहां पे, ठीक है। वी गो विद द न्यूक्लियर रिएक्शंस, ठीक है। वी डील विद द यूरेनियम एंड थोरियम, ठीक है। उनमें कैसे कन्वर्जन्स होती हैं। इंडिया में पता है आपको यूरेनियम अबंडेंट में है कि थोरियम अबंडेंट में है? In India, we have a resource for uranium or thorium.
So in Hyderabad there is uranium mine. I think.
Uranium is present in India in very less amount.
Okay.
Thorium is abundant in India. ठीक है, so they use thorium to convert it to uranium.
Okay, sir.
तो इसके बारे में भी देख लेना, ठीक है। तो बस आंसर थोड़ा ठीक है आपने, बाकी तो आपका कॉन्फिडेंस ठीक था, वे ऑफ एक्सप्रेशन आपका ठीक था, ठीक है। कुछ चीजें जो गलत, ग्रुप थ्योरी में यार, ग्रुप थ्योरी आपने टॉपिक चूज तो कर लिया, बट ग्रुप थ्योरी जो है दैट इज वेरी वास्ट टॉपिक। मैंने आपको पहले भी कहा था अच्छी तरह पढ़ लो ग्रुप थ्योरी। अभी तो पूछा ही नहीं मैंने ग्रुप थ्योरी के बारे में कुछ, बहुत बेसिक सा पूछा था अभी।
Yes.
चलो ठीक है सर।
ओके मैम, एनी फीडबैक फ्रॉम योर साइड?
तो मेरा भी यही पॉइंट थे, जैसे सर ने बताया कि जो टॉपिक्स इन्होंने बोले हैं उनका अच्छे से होल्ड ग्रिप इनका होना चाहिए, जो कि नहीं लगा। और कोई भी अगर क्वेश्चन का आंसर करना है तो पहले आप, अगर इफ यू कैन, तो पहले आप उसको लिख कर देख लो। जैसे हेबस प्रोसेस ही पूछा था, आप पहले उसको लिख करके देख लो, देन आंसर इधर इट इज एंडोथर्मिक और इट इज एक्सोथर्मिक इन नेचर, ठीक है। डिफरेंट पर्सपेक्टिव से आप थोड़ा देखो, आपको टाइम देंगे वो बार्क वाले, ठीक है। और ऐसा भी होगा कि वो कैन गिव यू हिंट्स आल्सो, ठीक है। एकदम से जंप नहीं कर जाना आंसर में, ठीक है। तो थोड़ा रिएक्शंस को या उनके क्वेश्चंस को अच्छे से सुनो और थोड़ा टाइम लेके फिर आप आंसर करो, दैट विल बी गुड। और वही है, थ्योरेटिक क्वेश्चंस अगर आपसे पूछो तो आप फटाफट आंसर कर दे रहे हो, पर थोड़ा सा प्रैक्टिकल यूटिलिटी की तरफ जा रहे हैं तो आप थोड़ा कभी बीच में ऐसे लग रहे हैं गोल गोल भी घूम रहे हो, ठीक है। तो वहां थोड़ा आप पता चल रहा है कि आप थ्योरेटिक और प्रैक्टिकल नॉलेज को आप कोरिलेट नहीं कर पा रहे, तो इस चीज पे थोड़ा सा ध्यान दो, है ना। कॉन्फिडेंस,
ठीक है। और कोर्स तो स्टार्टिंग में मैंने पूछा कि भाई क्या आपका एम है, तो बताओ ना कि सर मेरे को तो ये ड्रीम है मेरा साइंटिस्ट बनना।
यस
उसमें क्यों घबरा रहे हो?
हाँ जी।
मेरा तो ये मतलब बहुत अच्छी अपॉर्चुनिटी है, मैं साइंटिस्ट ही बनना चाहता हूँ बचपन से, और मैं रिसर्च करना चाहता हूँ, मतलब प्रोजेक्ट, मतलब अलग अलग इस तरीके से कुछ बनाओ ना उसको, ठीक है।
अपनी सेल्फ इंट्रोडक्शन जो है ना वो आप स्टेप वाइज मैनर में नोट ही बना लो, लाइक 4 to 5 लाइंस का ना अपना सेल्फ इंट्रोडक्टरी नोट बना लो। और ये क्वेश्चन आपको पूछा ही जाएगा, जैसे कि सर ने पूछा कि आप अपने आप को कहाँ देखना चाहोगे, या मतलब आपका क्या एम है लाइफ का, या आफ्टर 5 to 6 years आप अपने आप को एज एन क्या देखना चाहते हो, ठीक है। कौन से पोजीशन पे खड़ा देखना चाहते हो, तो ये क्वेश्चंस आपसे पूछे जाएंगे। इनको आप एक अच्छे से आप नेट की हेल्प लो, अच्छे से प्रिपेयर कर लो अपनी सेल्फ इंट्रोडक्शन। इट शुड बी क्रिस्प और क्लियर।
Yes, ma'am.
चलो, ओके, ऑल द बेस्ट।
ऑल द बेस्ट।